Assalamu alaikum everyone. I'm Abdul Majid. Once again, just to start your another class of chemistry, and it will be your lecture number 10. Okay. So what will be our, as usual, aims, goals, and objective today? Again, we will be doing some revision very briefly. What else? We'll cover another law of multiple proportion. And I told you yesterday, you should bring your calculators with you. So I hope you should have. So we'll start also what? The molecular mass. So what is the brief revision? You know that we have started chapter number 2. And we are doing the first topic, laws of chemical reaction. You can see on the screen there are 4 laws. Out of these 4 laws, we have covered 2 laws. And today we'll be covering the third one, the law of multiple proportion. What was the first law of conservation of mass? Very simple. You can't create any matter, you can't destroy matter. In any chemical reaction or in any physical change, the only thing that we can do is to transform matter from one form to another form. Means only rearrangement of atoms is there, but the production or the destruction of atoms is not possible. Second one that we have done yesterday, that was all about law of constant composition. Means if the thing is pure, it always contains a fixed quantity of elements. Like water is there. If the water is pure, it only contains hydrogen and oxygen, right? Which combined in a fixed ratio. The formula of water H2O, it means 2 hydrogen and 1 oxygen. Okay? If there is something else, it will not be water. It will be different. Like I gave you an example, H2O2, it's not water, it's hydrogen peroxide. Okay? So that these were the 2 laws that we have covered the day before yesterday and before that day. Now today's topic is law of multiple proportion. Law of multiple proportion. What's the law? Before we start the law, there's a question for you. There's a question in your mind might be, we all know that atoms combine chemically to form a compound. Carbon and oxygen, carbon dioxide. Hydrogen and oxygen, water. Carbon, hydrogen and oxygen, glucose. Now the question is, when 2 elements combine, then only one type of compound is formed. If you are clever, you already know the answer. Because we have just discussed a few minutes ago its answer indirectly. What is the question written that you can see on the screen also? Is it possible 2 different atoms can combine chemically in number of ways to form number of compounds, different compounds? If yes, then how could it be possible? Okay, so the answer of this question was given by Mr. John Dalton, right? He showed that yes, 2 elements can combine to form more than one compound. Example just discussed, hydrogen and oxygen. They are combining to form H2O, water. And under different conditions, they may also form H2O2, hydrogen peroxide. Okay? So one thing is clear, that there are the possibilities that 2 elements, the 2 same elements may combine to give different types of compounds. Okay? So he observed something. He observed a trend. He observed a law, and he gave it in the form of law of multiple proportion. If two elements combine to form more than one compound, this statement is a little bit confusing. Before I read this or tell you this statement, let me tell you something on the board. See, what have we just discussed? Hydrogen and oxygen. I hope you can see it easily. They may form H2O, or they may form H2O2. How many hydrogens? 2. How many oxygens? 1. How many hydrogens? 2. How many oxygens? 2. So what have you observed here? Out of these two, the value of hydrogen, the number of hydrogen, the mass of hydrogen is fixed. 2. 2. Whereas if it is fixed, if the first one is fixed, then there's a change in the second one. 1, 2. Okay? I'm supposing if there is another one, then what could be next? H2O3, it's a supposed. So just to put some weight, that hydrogen's contribution remains constant, whereas the contribution, the mass, the value, the quantity of the other element changes in whole number ratio. Okay? Another example. What is that example? See. Carbon and oxygen can combine to form carbon monoxide or carbon dioxide. So can you guess which element is in fixed ratio and which element ratio is changing? Yes, carbon is fixed, 1:1. How many carbons? 1. How many oxygens? 1. So the ratio is 1:1. 1:2. If there is another one, supposed, it should be 1:4, 1:3. If there is another one, like CO4, it's 1:4. So what have you observed here? The quantity, the mass, the contribution of one of the element is fixed, whereas the other element is participating, in whole number ratio. 1, 2, 3. All right? So here comes the law. Here comes the law. So what is the statement over here? What is the statement over here? See, read the statement by yourself. Considering this example that I have given on the board, read it by yourself. When two elements combine to form two or more than different chemical compounds, then the masses of one of the element, like we have oxygen over here, then the masses of one of the elements which combine with a fixed mass of the other, like carbon, like hydrogen. Confused? No problem. you will understand it easily. If you understand it 50%, it's okay. Okay, so what about that element which is combined, whose value is changing? That bears a simple ratio to one another. To one another. Remember, two elements forming different compounds. Mass of the one element will be fixed. Mass of the second element will change in whole number ratio, not in fractions. See in the example. This is another different view of the same topic. Look at the board. We have just talked about it. H2O, H2O2. Numbers 2:1. Numbers 2:2. Its value is 2:1. Its value is 2:2. What does it mean? Hydrogen's ratio is fixed. Oxygen's ratio is changing in whole number ratio. Now another way to tell about it. Last day, I told you how to find its mass. What is the mass of hydrogen? 1. How many hydrogens? 2. 1 2s are 2. What is the mass of oxygen? 16. How we got this 2? See again. Mass of one hydrogen is just 1. How many hydrogen do we have? 2. So 1 2s are 2. That's why I wrote here 2. How many oxygen? 16. Its mass is 16. So here 2 hydrogens. Again 1 into 2. Can you tell me what will I write here? It's O2. What is the mass of one oxygen? 16. How many oxygens do we have here? 2. 16 to the 32. So this is another way to look this law in terms of masses. First we have seen in terms of numbers. 2 hydrogens, 1 oxygen, 2 hydrogen, 2 oxygen. Oxygen changes. Now we are studying the same in a different way. What is the mass of hydrogen in this compound? 2. What is the mass of hydrogen in this compound? 2. So the mass of hydrogen is fixed. What is the mass of oxygen in the first one? What is the mass of oxygen in the second two? In the second one? 16. 32. Ratio 16 1 the 16, 16 to the 32. 16, the double of 16 is 32. So the ratio is existing. Okay, so what will you understand? What will you memorize? That the mass of one element, the value, the quantity, the number of one element is fixed, the other one changes, the other in whole number ratio. See other example. As you can see on the screen, just highlighting it. What is the mass of oxygen? 16 and 32. It's in simple whole number ratio. If there is suppose another compound, then 16, 32, that would be 48. Okay? If you simplify it, 16 to the 16, 16 to the 32, the ratio will be a whole number ratio. So one is fixed, other one is changing. This one is scanned from your book. Carbon monoxide and carbon dioxide, just gave its example. Let me explain it here on the board also. Carbon monoxide, carbon dioxide. First, talk about by the numbers 1 carbon, 1 oxygen, 1 carbon, 2 oxygen. So we know that the contribution of carbon is constant, is fixed, whereas the other one is changing. Let's see the same in terms of their masses. What is the mass of single carbon atom? 12. What is the mass of single oxygen atom? 16. What is the mass of one carbon atom? 12. What is the mass of one oxygen? 16. How many oxygens? 2. 16 to the 32. So I think now you can see the out of carbon and oxygen, carbon's contribution is fixed, whereas the contribution of oxygen by mass is in whole number ratio. 16, 32. Okay? So this was an example from your book. Another example from your book. Nitrogen and oxygen. When they combine under different conditions, they form different compounds. A series of 5 compounds which are included in our syllabus. The first one is NO, N2O. Now take it as an assignment. N2, what is the mass of nitrogen? 14. How many nitrogens? 2. 14 twos are 28. So in the first column is written mass of nitrogen 28. O, in the next column is written 16. Just below it, NO, what is the mass of nitrogen? 14 is there because there is only one nitrogen. And what is the mass of oxygen? 16, 14 and 16. If you multiply it by 2, look at the screen. We are multiplying by the same value. So overall there will be no net change at all. So we can write it like this. See the third one, N2O3. N2 means 14 mass of nitrogen, 2 nitrogen are there, 14 to the 28. Then oxygen 16 is the 48. Then the next one, all right. So you can see from nitrogen's column that the mass of nitrogen is constant, whereas the mass of oxygen is changing in simple whole number ratio, 16, 32, 48, 64, etc. All right. Now, or if you want to simplify it, you can see in the next 2 columns. So in these columns, the mass of nitrogen is divided by 2, it changes into 14. In the next one, dividing by 16, 16 to the 16, 16 to the 32, 16 to the, so we get the last one. So you can see in the last 2 columns, the mass of nitrogen is fixed, whereas the mass of oxygen is in simple whole number ratio. All right. So nothing so much explanation in it, just give 2 or 3 examples. Okay, so we have covered the laws. Today's last part. We'll start in a minute. You should have your calculator with you, molecular mass. It's really too hot over here. All right. Yesterday, I told you something about molecule. Correct? Remember? 2 or more than 2 atoms combine to form a molecule. Means molecule is a combination of atoms. which are joined chemically, which are joined permanently. Like we have the molecule of water, H2O, like we have the molecule of carbon dioxide, CO2. Okay? One more thing I told you yesterday, atomic mass, mass number. Atomic mass means sum of proton and neutron. Atomic number means number of protons. Just recall your memory. If you see a symbol like calcium, yeah, or calcium, 1940. A symbol is there, simple. Then what is the atomic number of calcium? 19, because I told you the smaller number always represent what? The atomic number. And the bigger number represents what? The mass number. Or sometimes it is also called atomic mass. Even there is little bit, very little bit difference in atomic mass and mass number. Okay? So this is mass number. So we are going to use these mass numbers in our upcoming numericals. Okay? So having brief revision of atomic number, mass number, molecule, let's see what is the question here. Calculate the molecular masses of this. Like we found the molecular mass of carbon dioxide just in the previous topic. Okay, the question is there. So which is the first one? H2SO4. What is its name? Good. Sulfuric acid. Now it is asked to find the molecular mass of sulfuric acid. Okay? So there are different ways, there are different methods to find this mass. Okay? The two methods I'm showing it to you, you can use other methods too if you know it. Okay, to find these molecular masses, we should know some common atomic masses. For example, the atomic mass of carbon is 12, the atomic mass of hydrogen is 1, oxygen 16, nitrogen 14, sulfur 32, sodium 23, calcium 40, aluminum 27, silicon 28, and so on. It will be given to you in the end of the question paper. Anyway, so you can see on the screen, molecular atomic masses are given, and you are going to find out the atomic mass of the first one. See on the screen. So I name it first one method as vertical method. So what will we do? First of all, we write the molecule that whose molecular mass we are going to find. Okay, H. What is the atomic mass of hydrogen? 1. That is why it's sitting there 1. How many hydrogen do we have? 2. So 1 2s are 2. Next is sulfur. What is the atomic mass of hydrogen? See from the book? 32. I mean from the table. 32. How many sulfurs? 1. 32 ones are 32. What is the atomic mass of oxygen? 16. How many oxygens? 4. Where is it in? H2SO4. 16 4s are 64. Just add them. 2 plus 32 plus 64, 98. It's just a way. I'll solve here on the board also. Another way, that is this I call horizontal method. The same, you will get the same answer. We'll write first the formula of H2SO4 and just below it how many hydrogens? 2 hydrogens. Sulfur 32 into 1. Oxygen 16 into 4. 2 ones are 2, 32 ones are 32, 64 is 64, 98 is the answer. All right? So I'll follow the same on the board. See this one? HNO3. First one is H. How many hydrogens? What is the mass of hydrogen? 1. How many hydrogens? 1. Next is N. N stands for nitrogen. From the table, what is the mass of nitrogen? See, 14. How many nitrogen we have? 1. Oxygen. Mass of one oxygen 16. How many oxygen? There are 3 oxygens. 48. Add them, we'll get 63. Okay? So try to do these two plus this one C6H12O6 just for practice. It's not an assignment. Or try to find out carbon dioxide. So tomorrow we'll continue from the same. The same topic will be continued. Is it clear? Just go through whatever I have just told you. Okay? So what would be the next? We continue molecular mass, molecular formula mass, molar mass, means masses. We'll practice, practice and practice. Basic concept of chemistry, you should know it. Okay? The most important thing is there, but it's very easy. You can finish it within 2 or 3 minutes. Just write down the atomic masses of this. And if you are very good, if you think that you are quite intelligent and responsible, you should remember, you should memorize these atomic masses. Like what is the atomic mass of carbon, what is the atomic mass of oxygen, this and that. These are the important ones. All right? If you have any question, let me know. And one most important thing I've heard, I didn't see myself yet because I was busy since from the morning. My kids, they were supposed to take the Zoom classes, and but I came to know that you people appreciated me a lot. Thanks a lot. Thank you so very much. I'll continue it. Thank you so much. Take care.